she was planning on starting.
I don't know if she was because we didn't have an email from her yet.
Yeah. But she
Maybe
could
she
have
was probably waiting for a
accidentally just
response
hit
from us.
like, reply to you instead of reply to all. I've done that so many times.
Yes.
It's confusing.
Me too.
Okay. So I might be a little bit skewed in what I can do for help because I already taken the exam. I just finished it.
Oh,
So
nice.
I can't and I took the review group quiz one time just for myself, but I didn't, and then I figured out everything I got wrong and how to do it right, but I haven't retaken it, so I'm still gonna take it with you guys. And I still have to figure out, and I think I know what ones I'm turning towards, but I'm still not sure which ones are right, necessarily, so.
Well, I worked through
So
all
did you take it this morning?
Yeah, I just finished it like half an hour ago.
Oh, okay.
So.
What were you gonna say, Marianne?
I did the textbook. I worked through that. And I think it's the same thing as the quiz, right?
Yeah, it's exactly
I
the
think
same.
so.
So I worked through
Oh,
that a
sweet.
few
Okay.
times before I even tried the quiz. And that was my tester to see if I was gonna totally bomb the exam or not. And I still wasn't sure if I had the questions right, but I got them to where I thought they were more right. And I watched the teacher's review thingy, her video. So.
Okay. Sweet.
Okay.
But I did well on the test, so that should give you guys hope.
Yeah. What did you get?
I got an 88. And I actually thought I would have gotten a little better than that.
Yeah.
Just I only felt unconfident on 2 questions. But I guess I missed a few more than 3 more than that. So that means that there's something I'm confident on that's probably not right, and that's makes me a little uneasy. But still, 88%. It only dropped my grade a tiny smidge, so it's good.
Good job.
Yeah. Well, well, you have an A in the class, don't you?
It's a 91, almost 92. D minus.
I think that's about what I got because I got the exact same score on the last test as you did. And then
Yeah, and I'll get better too because I didn't do so well on the practice quiz, this quiz, which I'm about to retake with you guys, because I had to not check that I met with the group and stuff. So
yeah,
I automatically failed that part. But I was I know I can retake it. So
yeah.
So that'll bring things up a little, hopefully.
Yeah.
Okay.
So
well,
yesterday.
What?
Yeah, I'm ready.
Oh, let me just
I gotta
move my video screen over here.
Yesterday my SPSS froze up.
Ooh.
So I didn't get to do through 22 and then 24 to 26. I'm pretty sure I know how to do those though, so it's not too big of a deal.
Okay.
Shall we start with Courtney, then Maddie, and then me?
Sounds good.
Okay, I'm getting into it now.
Number 2.
Okay. Given a 90% confidence interval of 105 for mean heart rate, which of the following is the best interpretation of this confidence interval? Well, we know that it's not chance because that deals with probability, and it's not a probability.
So, was it the homework at the beginning of the week that had this question? I kept getting it wrong.
I kept getting it wrong too.
I did the 2 that I thought were right, and they were both wrong. So, I was thinking it was the second one. We're 95% or 90% confident that the true mean rate is between 45 and 105.
I think that's right.
That's the one I think.
Because it's confident. It says it's supposed to be right. right?
Yeah. That's what I was thinking.
Because you can't say that 90% of all people, this is just for the means of our sample, not for the entire population. And then in her
Mhm.
review video, it said that chance is like a red flag for you if they say the word chance.
I did not know that.
Because it's not a probability. Yeah, watch her video, it's helpful. I
Yeah.
didn't think of that before, so.
Okay.
So I think you're
Yeah.
right with your hunch.
With what? Oh,
What,
okay.
what you thought it was, being the second one.
Okay. Well, hopefully. All right. Researchers at the University of Mississippi want to determine whether the reaction time in seconds to go, no-go stimulus of males differs from that of females. The researchers randomly select 20 females and 15 males to participate. The go, no-go stimulus required the students to respond to a particular stimulus and not to respond to other stimuli. The researchers decided to construct a confidence interval to determine if the difference of the means is significant. To determine whether the confidence interval would be reliable, they created a QQ plot of both random samples and see that they are approximately normal. Are the requirements for constructing a confidence interval satisfied? Why or why not? So one of the requirements is met, but they still have to figure out the variances, so I didn't know what to put on this one.
Yeah, I got this one wrong. So I'm with you guys. I'm trying to figure it out. So
Is it yes, the distribution of the mean of each sample is normal since the data have been determined to be normal?
well, but I mean, yeah, but is it a simple random sample?
The second part is right.
Did they say that? I mean, the sample size isn't large
Um,
enough, but because they determined it to be normal, then it's still okay.
Mhm. Yeah, but since it's where are my notes?
Let's see.
So this one is what, independent testing?
Well, either way, they're like all similar requirements, but yeah. Both populations are normal or the N1 or N2 are large. So if they're both determined to be normal and it's just either or for this sheet thing that you did. No, print out. Yeah, on that it just says that the requirements for independent is both populations are normal or the sample sizes are large.
Oh,
Plus
then I guess it would be that one.
yeah, maybe. This one still kind of confuses me.
Yeah. Because I guess I was looking at the requirements for ANOVA, and that one you have to do, they have to be distributed normally. And then, and the variances have to be done. But I guess there wouldn't be a
We
variance
wouldn't have
with
enough
this one.
information for that. It's not an SPSS document.
Okay.
I think it's just talking about two groups, males and females, and seeing their difference. So it would be a paired.
Would it be paired?
It would be the paired one.
Yeah, so either way, then it's just they have to be determined to be normal by like QQ plots, or the sample size is large.
And since we determined it was normal, then
yeah.
And they did randomly select. Yeah, I think you're good. I think we're good. Okay.
Yeah. Okay, my turn. Of the 4 types of confidence intervals listed below, which one is appropriate for this experiment? Oh, we just did that. So it would be the, let's see, I always have to figure out
Independent samples.
confident using dependent samples.
I'm gonna be independent.
Well, Marianne was
Because-
just saying that it was matched pairs, and Maddie, you were saying it was independent, so you got to decide between the two. I know the right answer to this one, so I'm not going to comment because I don't want to.
So this one,
mess things up or be unfair.
knowing the people in group 1 doesn't give you any details for group 2, which would make them independent. So I have an example in the notes. I think this one's from the book. It says, for independent samples, the samples comparing men and women's incomes, and it says knowing the names of the men will tell you nothing about which women are selected, which is the same thing here. Say just randomly picked men and women.
Mhm.
Okay, are we on question 5?
So are we choosing the independent sample then?
That's what I'm thinking. Do you still think it might be independent?
I don't know. I always get
You can both put your own different answers and then find out.
because the paired one has the mu difference.
Those are so confusing sometimes. Like, I have the hardest time figuring out things are like dependent or not, just because I'm trying to figure out like which aspect of being dependent they're talking about.
Mhm.
Let's see.
Okay.
I mean, if you put one in and it's not right, then you can take it again.
Sure.
Okay.
Okay, a researcher is interested in estimating the savings account balance of customers at a large bank. She obtains the savings account balance of a random sample of 30 customers. A 95% confidence interval for the mean savings account balance of bank customers is found to be blah, 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 blah. Which of the following would produce a confidence interval with a smaller margin of error than this 95% confidence interval? Okay.
Would it be the 99% confidence, or would it be using 90 balances?
So let's see, they want to produce a smaller margin of error. And in my notes, because I got this one wrong too, in my notes, to get a smaller margin of error, you have to increase the sample size. So is there an answer like that?
Yeah, it's obtain the balance of 90 customers instead of 30.
Yeah, I think it's probably that one.
That's the one that I put on the practice test. If we're also bumping it up to 95 or 99% confidence, then aren't we lowering the margin of error doing that too?
Because we're bumping up the confidence interval. That actually increases the margin of error. But if you increase the sample size, then you decrease the margin of error. So we don't want to increase it, we want to make it smaller. So that means we need to change the sample size, not the confidence interval. I'm just reading this in my notes. And I think I got that from the teacher's video that I watched.
Okay.
So we're saying to increase the
90 bank customers rather than 30.
Yeah, that's what I put as well on my practice one.
Yeah.
Okay. So decrease margin of error.
I watched her video like after I took this quiz, and it answered a lot more questions for me.
Yeah, her videos are pretty good. All right. A factory makes propeller drive shafts for ships. A quality assurance engineer at the factory needs to estimate the true mean length of the shafts. She randomly selects 4 drive shafts made at the factory, measures their lengths, and finds their sample mean to be 1,000 millimeters. The lengths are known to follow a normal distribution whose standard deviation is 2 millimeters. Calculate an 95% confidence interval for the true mean length of the shafts. Input your answers for the margin of error, lower bound and upper bound. Cool.
You guys have your printout with you, or like the thing that she sent us?
Yeah.
Okay. So in the one group, sigma known, because we know the standard deviation, there's the equation.
That's what I did.
Yeah, the interval. So I think we plug it all into that, and then the z-score would be 1 point, no, it's 95%. So it'd be 1.960, right?
Yeah. Got 998.04 and 1001.96.
Yeah, and yeah. So we just need to make sure we round those extra zeros on there.
Mm-hmm.
Okay.
Yep, I'm pretty sure that's how we do that one.
So how do you write it out in the actual thing?
Like, how do you write it out in the equation?
Like for the, so with the margin of error, we just put both of those numbers in, right?
Is the margin of error just 1.960?
Oh yeah, because don't we minus 1 from the other and divide by 2? No, wait.
Oh, yeah.
Because it's asking another question, basically, because there's like 32 questions on here when the actual thing only has 26, so it's actually asking us to just figure out one more thing. So that would be
So yeah.
1001.960, right? Because it's upper minus lower, minus
Yeah.
998.040. And then we divide it by 2.
Uh-huh.
That's just the z-score, ironically. Is it supposed to be that way?
I don't know.
Is that what you guys got, 1.960?
Yeah.
Okay, so that's the margin of error, and then the lower bound is 998.040,
Mm-hmm.
Sorry.
and then upper is 1001.960.
It's a fly around my head.
It's like the general conference moment where like they're on screen and like one lands right there. That's funny. I think it's Marianne's turn.
Okay, just
I
right
just like did 3 all at once.
I was just putting in the upper bound. Trying not to be distracted. Okay, number 9 says to assess the accuracy of a laboratory scale, a standard weight is known to weigh 1 gram, is repeatedly weighed a total of n times, and the mean of the weighings is computed. Suppose the scale readings are normally distributed with unknown mean and standard deviation of 0.01 gram. How large should n be so that the 95% confidence interval for you has a margin of error of 0.0001?
We have to
Okay.
use that equation that helps us find the sample size when sigma is known. Right, the n equals z times standard deviation divided by margin of error square rooted.
So when I did this, I used the I used the, let's see, equation. I think I used the margin of error equation. Is that what you're
Oh,
saying?
I'm sorry. Apparently, phones go through my camera. Decline. There's the button.
So I put m as the 0.0001 and the 1.96 for the z-score, and 0.01 is the deviation, and then solved for n.
Yep. And you square rooted it, right?
Yeah.
It's the
And
equation on her little sheet.
Yeah. So 38,416 was the answer.
That's what I got.
That's what I got.
Okay, my turn. All right, the mean area, mu, or of the population, of the several thousand apartments in a new development is advertised to be 1,250 square feet. A tenant group thinks that the apartments are smaller than advertised. They hire an engineer to measure a random sample of apartments to test their suspicion. The appropriate null and alternative hypotheses are the null and the alternative for the population mean are. All right, so they're obviously equal. And we think the population is smaller than it, right?
Yeah.
So alligators moving away.
Pointing toward the HA.
Huh?
The alligator's pointing toward the HA, right?
Yeah, the point part, yeah. That's what I was, yeah.
So the last one?
Yep.
Yeah. All right. In a statistical test of hypotheses, we say we reject the null hypothesis with the level of significance A if p-value is less than alpha.
Okay. A group of statistics students wants to determine if students in some apartment buildings get better grades than students in other apartment buildings. They collect GPAs from an anonymous random sample of 15 from each 4 different apartment buildings. The data for each apartment building are bell-shaped with no outliers, and sample variances are nearly equal. Can they use an ANOVA hypothesis test to answer their question?
I think so.
Yes.
Fit all the requirements for a ANOVA.
Yeah.
So
Yeah.
is it the longer yes answer or the shorter yes answer?
Longer.
Longer one.
Okay. Okay, I thought.
Okay, a medical researcher is working on a new treatment for a certain type of cancer. The average survival time of after diagnosis for the standard treatment is 2 years. So the null hypothesis is the average survival time after diagnosis is the same for the new treatment and the standard treatment. In an early trial, she tries the new treatment on 3 subjects who have an average survival time after diagnosis of 4.5 years. Even though the sample is small, the results are statistically significant at the 0.05 significance level. Consequently, she rejects the null hypothesis. In a future study, it is determined that the new treatment does not increase the mean survival time in the population of all patients with this particular type of cancer. The research has committed what error?
I put a type 1 error, but now I don't know if that's right.
Well, a type 1 error is when you reject a true hypothesis, right?
Yes.
Yes.
And they said
null.
if they found out that the treatment doesn't actually increase survival time. So she shouldn't have rejected the null.
Yeah.
So yeah,
So it was a type 1?
yeah, I think so.
Okay. If the level of significance is made very small, thereby making the probability of committing a type 1 error very small, what happens to the probability of committing a type 2 error? It increases the probability of a type 2.
By reducing it, right? By reducing a type 1, it increases a type 2.
That's what I think I chose. This fly. Away. Okay, my turn. I'm so distracted.
You must be like a really pesky fly.
Yeah, it's Florida.
Probably like
It's always
enormous size too, huh?
pesky bugs. Okay, the nicotine content in cigarettes of a certain brand is normally distributed with mean in milligrams and a known standard deviation of 0.17. The brand the brand advertises that the mean nicotine content of the cigarette is 1.5, but measures on a random sample of 100 cigarettes of this brand gives a sample mean of 1.53. Is this evidence that the mean nicotine content is actually higher than advertised? To answer this, test the hypothesis at a 0.5 level of significance. Okay. So for this one, I wrote out all the numbers that I knew, did a z-score, and put the z-score in.
What?
I got 0.0388. Is that right?
For the z-score?
P-value.
Oh. Let's see.
Which
So
equation did you use again? Was it,
I used z-score,
oh yeah, okay.
and then I got for z 1.765.
That's what I got. So do we, at that point, since it's trying to decide if it's greater than, do we only shade the right tail?
Yeah.
That was one thing I wasn't sure. When do we shade the middle and the right, and when do we shade only the right?
Well, probability is more when you do the middle. You're just like, or a percentile. But I don't
So
think you do the middle when you're doing tails. Because you'd only do one of the tails because you're doing a p-value.
Uh-huh.
Just like the sig tail. You only do the tails.
Yeah.
Okay, so you got 0.0388.
Yeah. Oy. So I put reject the null.
Yep.
Okay.
Whose turn is it now?
I think that was mine.
You would like to look at the mean number of hours worked for wages per week by male students and female students. You would like a random sample of 100 for each group and test if those means are different. What is the correct statistical procedure? So let's see, this is a 2-group test, so it's either going to be paired or independent. And isn't this the same sort of thing where like how much a male makes doesn't determine how much a female makes?
Mhm.
Yeah. Yeah, I think I put independent. Yeah.
I actually put independent for the last one too on my practice test, so I realized I must have just been being mixed up. So,
Okay.
um, so independent.
Yeah.
All right. An educator is interested in academic achievement by males and females with similar academic support systems. She decides to use brothers and sisters raised in the same home. Furthermore, she decides to use only brothers and sister pairs when they are next to each other in the sibling order. She should use a hypothesis test based on independent or dependent sampling. So that one would be dependent.
Because they're all raised in the same home, right?
So is it dependent?
So yeah, and it'll be if you select a brother to compare to his academic achievement to his sister, you must include the sister.
Yeah, because they're in sibling order. They were very precise on who did that.
Yeah, one does tell you who will be in the group too.
Okay. Okay, so number 18, a soil scientist collects random soil samples from a field of measured and dissolved organic carbon level of each sample. The measurements are recorded in the file. The researcher would like to construct a 95% confidence interval for the mean dissolved organic carbon level in the field. Of the 4 types of confidence intervals listed, which one is appropriate for this situation? Let's see.
It's just one sample, right? Because it's just doing it from
Yeah.
one field.
With sigma unknown?
Yeah.
Yeah, that's what I put.
Okay. Which of the following is the 95% confidence interval for this analyst? And put your answers for the margin of error, lower bound, and upper bound.
So this one, I got 11.168 and 15. For the upper and lower bound.
Yeah, that's what I got for the practice test too.
Mm-hmm.
So if we do the margin of error, that we just minus 15.
7.
Is it a point or is that a comma? It's a point. Huh.
Yeah, I think so. I had to look at that too.
Okay. So 15, 17.
So that is 0245.
Wait, you said so the margin of error is 2.025, right?
Yes.
Yeah, that's what I got. Is that what you got, Marianne?
Yes, that's what I got. So that would be 2.025.
Yeah.
Because rounding.
Yeah. So 11.168. And 15.217. All right. Courtney, did you just go?
Yeah, we just did like 3, so yeah.
Okay. All right, we ready for the next one then?
Mhm.
Okay. A random sample of Hummers for sale in Los Angeles and New York were taken from listings at cars.com. The data are recorded in that one. We want to know if there's a difference in mean listing prices between Hummers for sale in LA and Hummers for sale in New York. Create a 95% confidence interval for the true difference of mean listing prices between the 2 cities. Of the 4 types of confidence intervals listed below, which one is appropriate for this situation? I put independent samples.
Yeah, because the prices that one Hummer or in Los Angeles isn't going to be dependent on
So yeah,
prices theirs.
is it going to change the Hummers that we look at in the other one?
Okay. Calculate the 95% confidence interval for the true difference of mean listing prices between Hummers from LA and New York. Input your answers for the lower bound and upper bound.
Oh,
I got -423 and 5417. Is that the lower and upper bound?
I think that's what I got, but I think this is also my computer decided to freeze.
Yeah, you have to have the decimals in there. So you can't just use what.
Have to actually go in there and do it.
Yeah, I know their answer doesn't give us the decimals because this is what I think happened to me because I got this one wrong, but every time I do it, I keep thinking it's that same answer. And so I think what happens is I forgot when I did this test the first time to put decimals in.
So let's go in there and actually do it.
Yeah.
I wrote them down, but I'll let you guys figure it out again too. It's good to practice.
Use Hummers.
And then we'll make sure we have the same ones.
What was the file called again?
Used Hummers.
Used Hummers. Okay.
I'm glad you guys all
All right,
got the
let's look
same
for
answer
words.
too, because I was like, I swear this is right.
Yeah.
So for this one, refresh my mind. How are we doing this again?
So we have to auto recode first, and you choose cities to recode.
Oh yeah, because it's by city.
Yeah.
Okay.
And I hope this is not gonna freeze again.
Okay. So now, oops. We're doing price, right?
Yeah, you're measuring the listing prices.
Okay, so this one we go to descriptive stats, right, and explore. After we recode.
Because we decided this was an independent one, right?
Yeah.
Oh,
So you
okay.
independent sample t-test.
Compare means.
And then you define
Okay.
the groups.
So price.
Okay. So
Why isn't it? Oh, we gotta define groups. Okay. What are we looking for on this one again?
The decimals on the
The upper
confidence
and lower
interval.
bounds.
yeah. So is it 423.158?
Negative.
That's what I
Oh,
have.
Negative.
Yeah.
And then I got for uppers 5417.256.
Yeah.
Great.
5417. Oh no.
Okay.
I think it's my turn next. Okay. Many studies have suggested that there is a link between exercise and healthy bones. Exercise stresses the bones, and this causes them to get stronger. One study examined the effect of jumping on the bone density of growing rats. There were 3 groups. Rats were selected at random for the 3 groups. A control with no jumping, a low jump group, and the jump height was 30 centimeters, and a high jump group. So we had 3 groups so far, 60 centimeters. After 8 weeks of 10 jumps per day, 5 days per week, the bone density of the rats expressed in that much measurements was measured. This data is recorded in that. Researchers would like to determine if the mean levels of bone density are different between the 3 different groups of rats listed. 0.05 levels. So that's an ANOVA, because there's 3 groups. If we test statistic, we have to go in and do that. Unless you guys think you know it from your answers on the thingy.
I got
No.
I got
Huh?
7.978.
That's what I thought it was. What did you get, Maddie?
This is where my computer froze, so I didn't get
Oh.
to do the actual.
Oh, okay. Yeah, it'd be
That
good
part.
to do it.
Yeah.
Go in and do it. Let's see.
ANOVA's pretty fast usually. Maybe because that's more fresh on my mind at least.
It's called bone.
Exercise bone density.
Oh, exercise bone density. Okay, so we need to recode it, right?
Yes, I believe so. So it'll be the treatment. We'll do rat bone density independent and then group code in factor.
I'll be done in like 10 minutes. You can go take it off.
And then don't forget to go to options. All right, we're looking for the T-score, or F. Looking for F.
Mm-hmm.
So I have 7.978. So we're good.
And then the p-value is 0.002, right?
That's what I got.
Yep.
So then our conclusion, next question, is, let's see, it's smaller than it, so we would reject it.
Which means that what there's sufficient evidence.
That at least one is different, right? It's the at least one because it's a ANOVA.
Mm-hmm. So let's see.
No, isn't that D?
Oh, sorry, I was looking at.
Usually there's 4, this time there's 5. Tricky.
Yeah, so it's the second to last one on mine.
Yeah. Same.
Cool.
That's interesting. It's the last one on mine, I think. Oh, wait, no. Sorry, I didn't scroll.
You're like, panic.
Yeah. Okay. Yeah.
Okay. Is it my turn again?
Yeah.
Probably.
Okay. Pressures of supply and demand act directly on the prices for an airline ticket. As the seats available on the plane begin to fill, airlines raise the price. If seats on a flight do not sell well, an airline may discount the tickets or even cancel the flight. A study was undertaken to determine if there is a difference in the mean cost of an airline ticket purchased 90 days in advance of a scheduled flight compared with the ticket purchased only 14 days in advance. Data were collected on the cost of one-way ticket from London Heathrow Airport to a variety of destinations in Europe. The lowest published ticket prices of one-way flights from Heathrow to various destinations in Europe was recorded for each scheduled flight 90 days in advance and then again 14 days in advance. And that's what you click. Perform a hypothesis test to determine if there's a difference in the mean cost of the nonstop flights when a ticket are purchased 14 days in advance compared to 90 days. Use a level significance of 0.1 for the next 4 questions. Do 14 days, then 90 days for the analysis. Oh, 14 minus 90. Okay, so I put independent sample test on this one too. Oh, what is the correct hypothesis for this test?
I was thinking,
Oh, wait.
Isn't
Is
it
it?
dependent because they're looking for the difference and they want us to do 14 days minus 90 days, which you do in a compare test?
it'd be the same flight, but the ticket price at 14 days and the ticket price at 90 days.
Yeah, they're wanting to see the difference, so they're depending on one of the 14 days to figure out the 90 days and the 90 days to figure out the 14 days.
Yeah, so it would be matched pairs.
Yeah, I think so.
So dependent.
Okay. So calculate the test statistic. So the file is direct flight costs.
What did you think it was when you did the group work?
I thought it was 1.685.
That's what I thought too.
Okay. So this one,
All right, so we have to do what, auto recode first? Oh no, this one's different.
Well, you find the difference, so you do the compare variables.
Yeah.
If it's not coded, we might need to do the coding too. So it does which group for which.
So we do 14 minus 90.
This one is such a long one. There's like so many, so much data.
Yeah.
is it possible to just do, to take the, to go up into the analyze, compare means, and do the paired sample t-test without doing all this?
Well, I think you do have to code the city first, actually. Because that's how you figure out which prices are 90 and which ones are no.
Well, they're just side by side.
Where are they? I'm just not finding it.
Yeah, so it says before you do anything, subtract the computation. So that's the compare or compute variable. And then
Oh, I was looking at the wrong SPSS. For some reason, I got confused and thought we were still doing the Hummer one for a second there.
Yeah, there's a lot of files open.
That would, I know, I have so many. That would
So
explain.
then, do we go to descriptive statistics then and go to explore after we've done the subtracting?
I think so.
Pulling it up right now, the real one. Yeah, so we just do the difference of the two in the compute variable, and then you do independent. No, you do one sample t-test.
One sample t.
Is that what you're asking? Because this is a matched pair,
Yeah.
right? We determined. Yeah, it's dependent. So for dependence, you just do one sample. Because they're
Okay.
dependent.
So then you do the difference in the test variable.
Mm-hmm.
And then what is the test value again? Is that one 0 right now?
Yeah, and make sure that you put it at 90% confidence interval because we're doing 0.10.
Oh yeah, I forgot about that.
Man, I'm rusty on this one. Okay. So T is, I have 1.685.
Yep, that's what we just got. And then p-value 0.096, right?
Mhm.
Yep. Okay. Yay, last question.
Woohoo! So let's see, it is smaller than R alpha, 0.96, smaller than, no. Yeah,
Uh-huh.
Yeah, because we did 0.1.
uh-huh.
Yep.
So that means there's sufficient
So-
evidence.
That there is a difference in the mean cost of tickets.
So,
So the
Mhm.
second one, right?
Looks like it.
yeah.
Okay.
Okay, Marianne, did you say that you figured out that you were confused between independent and dependence?
Yeah, I
Did
realized
you
that.
fix the one up above?
I did.
Okay, great. Well, then let's do it.
All right, let's see. Yay, 100%.
Really? I got 96. What did I do wrong?
Yeah.
I think I must have. Question 15 was supposed to be reject the, oh, I see what I did. I accidentally hit reject the null instead of reject the,
Oh.
alternative instead of the null.
Oh, bummer.
The little a or the 0.
Yeah, I'm surprised I didn't get that mixed up too.
I've done that a few
Notice.
times. It's frustrating. But it's still good. It's like a 97%.
Yeah.
Yeah. Wow. Great.
Sweet.
Guys feel more confident
Well,
Yeah.
for the test?
yep, I'm gonna have to go study matched paired before I take the
Yeah.
test.
Yeah. I studied like all day yesterday. But it was
That
worth
was my
it.
goal, so it didn't really happen.
Yeah.
Okay, well, just put, who's putting this? Marianne, you did the link, right?
Yeah, I'm gonna do the link. And
Do you want me to do it next time? Since Nicole's not here to vouch for herself.
that'll probably be good.
Okay, I'll conduct.
Sweet.
Okay.
All right, see you guys.